This is the Earth Science Classroom. Welcome back to the channel. This video is on the seismology and earthquake playlist. We're looking at today is the S wave. It is one of the seismic waves that come out of an earthquake that are released, and we're going to look at the characteristics and properties and propagation of this S wave and look at the demonstration I would do with the rope in class for the students, and you'll see a video on this, and let's check it out.
Alright, so now we're on to the second kind of wave that comes out of the earthquake. We did the P wave, which was a straight line with the slinky. Now we're using this nice tug-of-war rope from phys ed that I kindly borrowed. And we're going to demonstrate the next wave called the S wave. The S wave stands for secondary or shear wave. Now shear goes side to side, so it goes perpendicular to the direction of movement. So that is called propagation. It goes from when the energy goes from myself, Ms. Wilkins, that is called propagation, the direction of energy movements. Now, this wave is going to go in a side-to-side or a snake kind of way. So the energy wave does this pretty much. Okay, so imagine the crust, the Earth's surface doing this. The energy is coming from me. Right, I'm the earthquake foci, or focus, where the earthquake happens on the fault line, or the rupture, and the energy is transferred in this kind of way. It's a side-to-side movement, and obviously the closer you are to the earthquake, the stronger the movement, or if you're further away, a few thousand kilometers, it will be a slower, less pronounced movement of the crust. We can imagine having a building, or a road, or a highway, and the surface is doing this. Plus, in addition, it's doing the P wave motion of back and forward, back and forward. So this is a S wave, stands for secondary or shear. It is not as fast as the P wave, but it still goes 3 to 5 kilometers every second through the crust. Now the cool thing about the S wave is, because it does this kind of propagation, this kind of way or style, it cannot go through any liquids. It goes down to the outer core, the core mantle boundary, about 2,800 kilometers below our feet. That is where you hit the outer core, which is liquid. It's a liquid hot iron alloy. And because it's liquid, the S wave cannot go through it. It literally gets stopped at the mantle core boundary. And that is because you need the rebound force in physics to move the energy. And when you do this with the rope, you'll see that it takes a lot of energy to keep the energy flowing through. And if it hits a liquid, it cannot do that. So there's no S waves through the core at all. So we call it the shadow zone. It creates a nice big S wave shadow zone where you cannot feel any S wave on the other side of the core. And I'll show that in class, what it looks like on a diagram, because it's hard to explain in this demonstration. But here is the S wave.
This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel, and don't forget to subscribe. Thank you again.